Okay, in lesson 2, we took a look at those squares and triangles again, and we learned that if you take a square and you fold it in half, you actually create two triangles. Okay, so just like we did in that original video, there's my square, and I'm just taking those two triangles and piecing them together to make one giant square. If I fold it, see how I'm flipping it over that diagonal line right there? That's what creates that duplicate copy. So these two are congruent. They are the same shape and same size. And if I rotate or flip it over, I can create a square. And if I take that triangle and break it down into two small parts, so if I take the triangle, this is the part I always have trouble with. It's like the sailboat. I gotta try to find it. There we go. Oh, sorry guys. I always have trouble finding the fold. It always confuses me a little bit. Okay. Here, maybe if I do it this way. There we go. Whew, that took me a few minutes. All right, see, even as an adult, sometimes it can get a little confusing. So if I take this triangle and I fold it in half, I create two. It's almost like a pyramid. Kind of reminds me like of a pyramid. See that? And two of these purple ones are the same as the green. And I have four of those. Okay, so I've got four of those that I can create to make a square. Remember, it looks like the envelope. Okay, so when we're working with shapes and composites, we can decompose a square to create smaller triangles. Now, the purple ones are worth 1/4 of the blue square. So if I take that blue square and I cut it into four parts, if I fold it in half and then fold it in half again, I've got four mini triangles, 1, 2, 3, 4. So each one of these triangles area is 1/4 of the square, or we could say half of one of the green triangles, right? Half of one of the green triangles. And we need two of the green triangles to make one giant square. So the green triangles are worth half of the square. So 1/2 plus 1/2 makes a whole. And then the 1/4 plus another 1/4 plus another 1/4 plus another 1/4 makes a whole. Okay, so that's what this summary is really showing you here, that you can decompose a square into two triangles, and then you can take that triangle and decompose it into two smaller triangles. All of them, though, add up to be the same area as the square. Okay, let's take this away. I'm going to skip question number 1 for the practice problems for lesson 2, but I would like to take a look at number 2. Priya decomposed a square into 16 smaller equal-sized squares, and then she cut out 4 of the small squares and attached them around the outside to make this new figure. How does the area of her new figure compare to that of the original? Now, I want you to notice that this area inside has been removed. It's been removed and cut out. So I'm going to show you where that is in the original shape. It's right here. In the original shape, she took this and she cut this out. And she took each one of those 1, 2, 3, 4 squares and she reorganized them outside of the shape. So she moved it out here. She moved one over here. She moved one down here. And she moved one over here. Okay? Now, do they have the same area? Well, if she just took this 4 squares out of the center and then broke them apart and just put them on the outside, they have the same area. And we can prove this by simply counting the squares. So I know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And inside we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. They have the same area. Okay, all Priya did was create something new with the same dimension. Okay, so I definitely want to circle B. The two figures have the same area. Okay, so all she did was take the original square, which was made up of 16 smaller squares. She cut out the center and she cut them up into smaller little pieces so she could take them and make almost like a pinwheel. Okay, it's like a little bit more creative design, but it's still the same area, same number of square units. Okay, this one is actually pretty fun. I like this question. So here we go, back with our shapes again. I'm telling you, this is great, guys. They're always here. So I'm just going to zoom out a little because that way we can see. What we have here is the same shapes that I cut out in the original video. I have the blue square, which is this shape. I have the small one, which is the purple, and the medium, which one is the green. Okay? And we're going to see which also has an area of 1.5 of the squares. So we know that we have the square, which would be the whole, plus a half, okay? So a half would be like the green one, right? So let's remove this purple, and here's 1.5. Okay, so if I have a square and I have a medium-sized triangle, that would be 1.5. And again, I think in the original video I showed you, that would be like a trapezoid, right? Like a trapezoid. So we have one whole square plus a half. So that would be an area of 1.5. Okay, so let's take a look at our choices. So if I take 3 of the small little ones, do I make 1.5? Now, I'm going to write on my little squares here. I'm going to write just so we don't forget. Remember that it takes 4 of these little ones to make a square. It takes 4. So this is going to be 1/4. This is going to be 1/4. This is 1/4. And this is 1/4. Well, if I only use 3 of them, like here, it kind of looks little like a, kind of like a bird. If I take and reproduce that, I have 1, 2, and 3. See if I can, there we go. Okay, I'm just reproducing what's on the paper. The little ones are only worth 1/4. So if I only have 3 of them, this is only 3/4. 3/4 of the square. I didn't even make a whole square. Remember, I need 4 of them to make a whole. So this one's 3/4. All right, not 1.5. Okay, what about this one? Now I just made this one. It's the square plus a medium triangle, but we could also make it out of 3 mediums. So watch, I'm going to show you that. Now, I don't have 3 of the mediums. Oh, yes, I do. I have the extra one from the last video. All right, so remember, it takes 2 of these to make a square. So I'm just going to show you, here's the square. I'm going to write each one of them. This is a half of a square, and this is half of a square. And I have another one, which is half of a square. See that? All right, so if I use 2 of them to make a square, so there's one whole, all right, see that? There it is. Boom, there's the whole square. So 2 of them make a whole square plus 1 more. There's your 1.5, okay? So 1 whole plus a half. 1/2 plus 1/2 plus 1/2. Altogether, that would be 3 halves, which is the same as 1.5. So we found one. This one will work. This is 1 whole and a half. So I'm just going to circle that one. All right, let's see if there's any more that we can make. Well, I see one of the giant triangles and one of the small. So I've got a medium and a small right here. So let's make it. All right, so I have one of my green ones. So there's a half. And then one of my purples. So if I have a half plus a 1/4, well, let's see. What does that equal? Well, remember, it takes 2 of these guys to be the same. Let me see if I can do this. Remember, I always have trouble. I always have trouble with this, trying to make it work. There we go. All right, let me flip it so we can see it. See, there's 1/4, and this one is 1/4. Remember the original 3/4, 1/4 plus 1/4 plus 1/4? Well, that's the same as this. So I've got 2 of the 1/4, which together make a half, plus one more 1/4. Altogether, that's the same as 3/4. And see that? Okay, so I just changed this green triangle into two small purple ones. 1/4, 1/4, 1/4. So we know that this is 3/4. Believe it or not, these two right here have the same area. All right, what about this last guy? Okay, well, let's see. I'm going to remove everything and start with a square because that's what we have in the center is the square. Remember, this is the hole. Now, what are these? Are these the small triangles or are they the medium triangles? Well, we can test it out by seeing which one lines up. Well, if I take this one and I make this shape up here, so you notice it doesn't cover the whole length of the square. So it must be this one. Well, we know it's this one because we know if we fold this in half, these sides will match. So we have, remember, this is 1 1/2, but look, there's one on the other side too. Let's see. This is equal to 2 squares because I have the one square in the center plus 2 halves that are opposite sides. But if I were to take them and fold them up together, I actually have 2 squares. So this one is actually equal to 2. So the only one that makes 1 1/2 is B. That one's the only one that makes 1 1/2. These two have the same area. They're 3/4, a little too small. This one is a little too big. So the only correct answer is B. Okay? All right, I'm going to skip question number 4 and I'm going to move over to question number 5. This one says, a student said, we can't find the area of the shaded region because the shape has so many different measurements. Instead of just a length and a width, we could multiply. Instead of just a length and a width that we could multiply. All right, so he's confused because he's like, there's no way we can find the area of this. Now, a lot of people are going to see the 60 and the 30, and they're going to multiply 60 times 30, and they're going to say that's the area. I want us to go back and remember the question that we did back in lesson 1, where we took 2 different looks at the shape. We can find the area of the shape. Yes, there's a lot going on here. Yes, it may be a little tricky, but we can do it. So one thing we could do is we could go inside the shape and partition it off in a lot of different places, but I am going to tell you that it might be tricky to do this because we have this shape that doesn't quite line up. See that? And then if we go across, this one would probably work out pretty good. But this guy right here is kind of throwing things off a little. So let's see if we can make the outside. I always like using that strategy because I find it a little bit easier to do. Let me get a straight edge. I'm going to use a ruler for this, not to measure, but just as a straight edge. So do you see how I want to connect at the top here? And I'm seeing that this is going to be like right about here. So I'm just kind of filling it in a little. My shape, it's not going to be perfect, but do you see how I'm doing this? I'm just going to kind of fill it in. I'm making it one big giant rectangle. I find this one the most fun to do. Okay, now we can take a look at what needs to be removed, the spaces that need to be removed from the total shape. So what I did is I made the 60, so now I have a base of 60 and I have a height of 30. So I could say that this is 60 times 30, using that annexing the 0 strategy. 6 times 3 is 18, annex 2 zeros, because we're multiplying by tens, and 10 times 10 is 100. Okay, so I know that the total outside area is 1,800 square units, okay? But that's not the answer. We're close. We've got to take out these 4 sections. Now, if I look at each one, I can see 2 are really easy. So here's my height. Here is my base. It's just upside down, right? So the base, typically the base is at the bottom, but if you rotate that around, the 15 is also at the bottom. Okay, so the base could be at the top or the bottom. So we've got 15 times 10 here. So I know that we have a 15 times 10. Using that same strategy, we're multiplying by 10 so we can annex the 0. And I'm going to do a little color coding here because I like color coding. Let's use orange. Okay, so here's the orange space area. We just took that out. Okay, we're going to subtract that from my 1800, but not yet. Let's get each part first. Okay, now I'm going to take a look at this one up here, and I can see it's the same. 10 and 15. See there, now the base is at the bottom. It's easier. So I'm going to take that out. I'm actually going to use orange again because it's literally the same. It's like two of the same pieces. 15 times 10, which is another 150. So now I can take 300 away from the shape because 150 plus 150 is 300. And then I got this last little one. Now this one's a little harder because I can see the base is 10. But what's the height? Now it looks like a square, but remember guys, we can't just guess. So what can we use to help us? Well, a couple things. I know the height is 30. I know the entire height is 30. So I'm going to put it over here as well so we can see it because it's this side of the shape. And then I can see that this is 10. Right here, from here to here is 10. See that? From here to here is 10. From here to here is 10. So that means this has to be 10 because 10 plus 10 plus 10 is 30. So if I know the height is 30, here's 10. Here's another 10, so this has to be 10. And 10 times 10 is 100. Okay, so now we know 10 times 10 is 100. So now I know that I can take 400 away from my total area. This all adds up to 400. Okay? That we're going to take away. Needs to be removed. Need to remove. That's what we need to remove from our total area. So 180, or 1,800, sorry, 1,800 minus 400. So the green space inside of the shape is 1,400 square units. Sometimes it is easier to approach it as a whole and subtract, take away the pieces that we need to take away, okay? And it was easier to find the area of those missing pieces than it was to actually find the smaller pieces on the inside of the shape, okay? All right, and I believe that's it. We'll take a look at lesson 3 in the next video.